See, first you will fill the 1s subshell, then you will fill 2s, then 2p, then 3s, 3p, 4s, 3d, 4p, 5s, 4d. This is order. You have to follow the arrow. Here the electrons are entering in 1s, 2s like this based on the energies. 1s subshell has the least amount of energy. Least energy. Least energy means more stability. When the electron enter in 1s, the stability will be more from the electron. This is nucleus. Okay. Nucleus is surrounded by the shells. In the nucleus, what are present? Protons and neutrons are present. Then the shell, this is the shell which is close to the nucleus is called first shell or K shell. Okay. How many subshells are present in it? One subshell is present, that is S subshell. Shell you can divide into subshell. This is shell and this is what? Subshell. This is second shell. Second shell is divided into two subshells, S and P. Third shell, S, P, D, three subshells. Fourth shell, S, P, D, F, four subshells are present. Like that, how many shells will be there in an atom? Infinite. If you take any atom, infinite shells are present in it. Any atom. Okay? Then S is subshell, P is subshell. Px, Py, Pz are the sub-subshells, means orbitals. Means again you are dividing the subshell into sub-subshells. P is divided into three, Px, Py and Pz. These are called as orbitals. Orbitals, sub-subshells. You can see here, in an atom there is a shell. Shell is represented by the letter N. Shell again contains what? Subshells. Subshell again contains what? Sub-subshells, which are called orbitals. And in that orbitals, electron will stay. So what is the location of the electron in an atom is orbitals. Where they are located? In the orbitals. Okay. So now if you take P, it is Px, Py, Pz. D, if you take, there are 5 orbitals, 5 subshells. Dxy, Dyz, Dxz, dx square minus y square and dz square. D orbitals are 5 in number. P orbitals are 3 in number. S orbital is 1 in number. Then if you take F, here they are 7 in number. F orbitals are 7 in numbers, means odd numbers. 1, 3, 5, 7 are the odd numbers. S is 1, P is 3, D is 5 and F is 7. Okay, now you are filling the 1s first, then you are filling 2s, then 2p. This is based on energy, right? This is also called as the Aufbau's building up principle. Aufbau's principle. Any element electron arrangement, that is electronic configuration, can be written using 3 golden principles. One is Aufbau's principle, second is Hund's rule, third is Pauli's exclusion principle. For any element or for any ion, if you want to write the electronic configuration, you have to follow the 3 golden principles. One is Aufbau's principle. Aufbau's principle means electrons will start filling the various subshells based on their energies. Means 1s is filled, then 2s, then 2p. That is called as Aufbau's principle. Then second one is Pauli's exclusion principle. What is Pauli's exclusion principle? Here you are following 1s, 2s, 2p, so on. Okay. In Pauli exclusion principle, each orbital can be accommodated maximum 2 electrons as suggested, right? Pauli will put a restriction that orbital should contain only 2 electrons, not more than 2 electrons. That's the maximum number of electrons the orbital can accommodate. Okay. Now say this is an orbital. Orbital we can show with the box or we can show with a line. Okay. So in orbital, how many electrons can be accommodated? Maximum two electrons can be accommodated. One electron with the upward arrow, other electron with the downward arrow. 2 is restricted. Poly is restricting maximum electrons in an orbital to 3W or 2. So what this principle says? An orbital can accommodate maximum 2 electrons only. Second point, that 2 electrons in an orbital must have opposite spin. Must have opposite spin. Electron can spin in 2 ways, clockwise and anti-clockwise. Clockwise and anti-clockwise. If the spin is clockwise, then it is plus half, shown with the upward arrow, or like this, half-headed arrow, full-headed arrow or half-headed arrow you can show. Then anti-clockwise direction if the electron is spinning, then it is minus half spin. You can show this with the downward arrow, like this or like this. So this is plus half and this is what? Minus half. 2 spins should be opposite. That's the Pauli exclusion principle. 3 electrons, if you put the Pauli will come in BT. So never put 3 electrons, 4 electrons, 5 electrons in orbital. Only maximum 2. Minimum how many electrons you can put? 1. Understand? Now my question is, suppose I am taking 2p orbital, okay? Maximum how many electrons you can put in? Maximum number of electrons is 2. If I take a 3D orbital, maximum how many electrons I can put? Only 2. What Pauli says? What is the orbital capacity maximum? Restricting maximum number of electrons in an orbital. When you see the word orbital contains 2 electrons only. That you should see. Orbital. Okay. Suppose if I give you like this, 2px orbital. Maximum how many electrons? 2. You should see this word here, orbital. Okay. Now if I ask you 2p subshell, maximum number of electrons, how many you can accommodate? 2p subshell. Should go back. 2p. P is divided into how many parts? 3. No? S cannot be divided. Okay? S subshell, S orbital are one and the same. P subshell you can divide into 3 parts. Pxy, Px, Py and Pz. D subshell you can divide into 5 parts. Dxy, Dyz, Dxz, Dx square minus y square and Dz square. F into 7. Understand? So now if I am asking you about 2p subshell, if you see the word subshell again contains what? Now 2p subshell contains 2px orbital, 2py orbital, 2pz orbital. What is the maximum capacity of each orbital?
2.
Yes. Maximum electrons 2. Maximum electrons 2. Maximum electrons 2. So if you sum this now, if you do the sum, so therefore this comes to how much? Total 6 electrons. Total is equal to 6 electrons. So a 2p subshell can accommodate maximum 6 electrons. Total 6 electrons in maximum can be accommodated. Is that clear? If I take 3D subshell, maximum how many electrons can be accommodated? How can? 3D subshell contains 3D xy orbital, 3D yz orbital, 3dxz orbital, 3dx squared minus y squared orbital, 3dz squared orbital. Don't worry about these terms here. X square minus y square, x square. Minus means you are not doing any subtraction here. Okay. Squaring means you are not doing any squaring. Don't break your head with this the letters xz, yz like that. Okay. So that is different story. So maximum how many electrons can be accommodated? 2 electrons. Maximum 2 electrons. Maximum 2 electrons. Maximum 2 electrons. Maximum 2 electrons. Now counting total 10 electrons here. Is that clear? So you should be very clear. Subshell he is asking or orbital he is asking. Okay. Now my question is, if you take fifth shell, maximum how many electrons can be accommodated in it? I also gave you the formula. What's the formula? If they are asking in a particular shell, how many number of maximum electrons that can be accommodated? Maximum. Okay. Formula is 2 into n squared. What n stands for here? N is the number of the shell. Shell number. Okay. What's the shell number here? 5. So what's the answer now? This is equal to 2 into 5 squared. 2 into what is 5 squared? 25. 25 into 5? 50 electrons. Means directly there is a formula here. No need to calculate again in fifth shell how many shells are there. Then in each shell how many subshells are, subshells are there. Like that, no need to do that. Okay, directly you are having the formula. Clear? Last one. Maximum number of electrons that can be accommodated in seventh shell. He is asking about the maximum number of electrons for the shell. And you know the shell number? Just now I said no. What is the formula for a shell calculation? 2n squared. So 2 into n squared, nothing but 2 into what is the shell number? 7. 7 squared. 2 into what is 7 7? 49. 49 double. 98. Okay. Third shell, maximum electrons. 2 calculation. 18. Formula 2 into n squared. What is the n value here? 3. So 2 into 3 squared. 2 into 9. Nothing but 18 electrons. Now how you are getting that 18 electrons? Third shell contains what? 3s, 3p and 3d. 3s you cannot divide it. 3s is 3s only. 3s subshell, 3s orbital. No division. Shell, subshell you cannot divide. Subshell and orbital one and the same. 3p if you take, it is categorized into 3 parts. 3px, 3py and 3pz. Then d if you take, d is categorized into 5. What are those 5? 3dxy, 3dyz, 3dzx, 3dx squared minus y squared, 3dz squared. Okay? Now you can put how many electrons maximum in 3s orbital. Any orbital can accommodate maximum 2 electrons. So 2 here, here 2, here 2, here 2, 2, 2, 2, 2, 2. Add it. Add all this. It's very easy. No confusion at all. But you should have the clarity. Shell contains, atom contains shell. Shell contains subshell. Subshell contains subshell. Is that clear? If they are asking how many maximum electrons can be accommodated in a shell, means there is a direct formula, 2n squared. See the shell number, substitute, that's all. If they ask in any orbital, maximum how many electrons are accommodated means 2. Many students will get confused here. If they ask question about orbital, they will think about the subshell. 3D orbital maximum electrons is, they'll say 10. That is wrong. 3D orbital is saying. Orbital maximum capacity is 2. Okay. We are seeing some anomalous configurations. Anomalous configurations, electronic configurations. For which elements we are seeing? Copper and zinc. Copper, not zinc. Chromium. Okay. First let me write chromium. Chromium atomic number how many? I gave you already. Already I gave you the atomic numbers. I told you to write the electronic configurations. Daily work we should do. Otherwise it will become a big amount. Atomic number is 24. Then copper. Atomic number 29. Okay. Now electronic configuration. You know this one, right? 1s, 2s, 3s, 4s, 5s. You will not go up to that one. 2p, 3p, 4p, 5p, 3p. Okay, here. 24 electrons you have to place. 2 electrons here, 2 electrons here, 6 electrons here. S can accommodate maximum 2. P can accommodate maximum 6 electrons. D can accommodate 10. F can accommodate 14. S how many? 2. P how many? 6. D 10. F 14. S how many? 2. P 6. D 10. F 14. Fixed. This will not change. Okay? So you should memorize 6 2. Next S. 2. Maximum 2. Now count how many electrons you have placed. 6. This is 10 and this is 2. 12. 2 2 4. 4 plus 6 10. 10 plus 2 12. Next 6. 18. 19 20. 20. Okay? Here how many you can place? Atomic number is 24. What does 24 atomic number indicates? What do you mean by atomic number? Proton number. Atomic number is proton number. Proton count. In nucleus you are counting how many protons are there. There are 24 protons. Chromium is an element, right? Element is made up of what? Element is made up of what? Any element you take. Hydrogen, oxygen, nitrogen, any element you take. What it is made up of? What it is made up of? Atoms. What is the building block of element? How it is built? This room, this wall is built with what? Bricks. Atoms. Bricks. Okay, bricks are the building blocks. So like that, if you take an element, element is made up of what? Atoms. If I take gold is the element, right? So if I take this much of gold, okay, gold, it's an element. What it is made up of? Gold atoms. Gold atoms. Gold atoms. These are gold atoms. The symbol for gold is AU. Capital A, small u, AU. Okay? If I take iron element, what it is made up of? If I take iron nail if I take, what it is made up of? Iron atoms. It contains iron atoms. If I take copper wire, copper is an element. What it is made up of? Copper atoms. Copper atoms are present. Understand? So chromium is an element. What it is made up of? Chromium atom. So if I take one chromium atom and if I see in the nucleus, how many protons it contains? 24 protons. And I already told that atom is electrically neutral. Atom do not have any charge. Atom do not have any charge. Atom do not have any charge. Nucleus has which charge? Nucleus. Atom lo unna nucleus. Ye charge untundi? Positive charge. Because in the nucleus what are present? Protons and neutrons. Protons are positively charged. Neutrons are neutral. So the charge of the nucleus is due to protons only. Because neutrons are not carrying any charge. So nucleus is positively charged. That positive charge is balanced by the electrons around the nucleus. Nucleus is surrounded by the electrons. Right? Electrons are continuously revolving around the nucleus. They will not stop. Right? Electrons will carry the negative charge. Nucleus is carrying the positive charge. How many protons are contained in the nucleus? That many electrons are present outside the nucleus. Nucleus lo any protons untayo anne electrons ekkada untayi nucleus bayita revolve avutuntayi always in a neutral atom. So there are 24 protons and 24 electrons present in chromium. What about copper? How many protons it contain? If I take copper atom in the nucleus, if I see how many protons are there? 29 protons. Outside that nucleus, how many electrons are revolving? Equal number of electrons. That is nothing but 29 electrons are revolving. Are you following? So now 24 electrons we have to place here. How many it is completed now? 20. 2, 2, 2, 6, 10, 12, 18, 19, 20. Now 4 electrons they will put in 3D. Now what is the electronic configuration? 1s2, 2s2, you should read like this. 1s squared, like this you should not read. 1s2, 2s squared, you should not read like that. 2s2, 2p, 6, 3s, 2, 3p, 6, then 4s2, 3d, 4. Okay? Now what about copper? 29. So you have placed how many here up to here? Okay. How much here? 20. 20. 9 we have to place. 9. Now what is the configuration? 1s2, 2s2, so p6, 3s2, 3p6, 4s2, 3p9. This is what we call electron arrangement. You are arranging the electrons. Electronic configuration is nothing but electron arrangement. Now, if you look at the experimental results, you will come to know that 4s is containing 1 electron and 3d is containing 5 electrons. Here you have done the filling of these electrons based on which principle? Which principle you have followed? Which principle you have followed? These electrons all you have placed based on which principle? No, this is based on opposite principle. 1s you are filling, then you are filling 2s, then you are filling 2p. That is based on what? Opposite principle. See, once have a look at the opposite principle. One s, electron entering 1s. After that, 2s. After that, 2p. Who is guiding us? How to fill the electron? Who is guiding us? Abbo is guiding. Abbo is telling, don't go in 2p, 2s first. First electron you have to place in what? 1s only. After filling 1s, go to the 2s. Then go to 2p. Like that, if you fill the electrons, the atom will get the stability. Atom will get stability. Is the stability done? Okay. Pauli exclusion principle, what it does? It restricts the maximum electrons in the orbital to 2. In 1s we are putting how many electrons? 2. 1s is the orbital and also subshell. It's a subshell as well as an orbital. 2 electrons they are putting, you are not putting 3. Right? And that electrons should be having the opposite spin this side. Right? There is one more principle here, that is Hund's rule. What is Hund's rule? It is also called Hund's rule of maximum multiplicity. So when it comes into play, Hund's rule कब लगाना है? ये could apply चाहिए Hund's rule. When you are filling the electrons in the degenerate orbitals. You are filling the electrons in degenerate orbitals. Now what is the meaning of degenerate orbitals? Degenerate orbitals. Degenerate orbitals means orbitals having equivalent energies. Equivalent means identical, means same. What are degenerate orbitals? These are the orbitals having equivalent or identical or same energies. Now what are the examples for these orbitals having the equivalent energies? P orbitals. P orbitals, Px, Py, Pz. These three orbitals will have same energy. Let us say this is the energy axis. Px energy ఇంత ఉంటుంది. Py energy కూడా ఇంతే ఉంటుంది. Pz energy కూడా ఇంతే ఉంటుంది. All the three orbitals have the same energy, equivalent energy. Now, if you take a d orbital, this is the energy axis. Okay? D orbitals are 5 in number: dxy, dyz, dxz, dx squared minus y squared, dz squared. So, all of these 5 orbitals have the same amount of energy, this much energy. They do not have different energies. Is that clear? So, like that, P, D, and F. F orbitals, how many they are in number? 7. They are 7 in number. Their names are complex to remember. Their shapes are also complex, right? So we do not discuss about the f orbitals. Just we will say there are 7 f orbitals. That's all. Okay? All the 7 orbitals will have equivalent energies. So what's the example here for the identical energies having orbitals? Example: what you are taking? E, D, F. We are not taking S. S orbital we are not taking. Okay? We are taking P, D, F. Understand? So these are the guidelines. Okay. So when you are filling the electrons, you should first follow the Gauss principle. According to the energies, you have to place the electrons. And when you are placing the electrons, you have to keep in mind that according to Pauli's distribution principle, each orbital can accommodate 2 maximum. Don't go beyond 2. Okay. Then third also you have to remember when you are filling the orbitals like p orbital, d orbital, f orbital. These are identical orbitals. Now what Hansul says? What is statement? A statement for Hansul. Each orbital should be singly occupied first with the same spin. Then pairing should be done with opposite spin. What Hansul states, each orbital means which orbital? P orbital means px, py, pz. Now you are filling the electrons in these orbitals. Each orbital, how many electrons you have to put? Single. Orbital capacity is to accommodate 2 electrons, but you should not put 2 electrons. You have to put 1 electron each in each orbital. ఒక్కొక్క ఆర్బిటల్ లో ఒక్కొక్క ఎలక్ట్రాన్ ముందు ప్లేస్ చేసుకోవాలి. Okay? Then with what? Same spin. Suppose let us say you are having 6 electrons. How many electrons? 6 electrons. First electron you have to put in px. Second electron you will not put in px, you will put in py. He is saying each orbital should be singly occupied first. Don't do the pairing first of all. Okay? So you should not do like this. Don't do like this. Don't do like this. This is wrong. Okay? Instead of that, let me take first 3 electrons. 3 electrons. So first electron, here I will put in px. Second electron, I should not put in px. Where I should put? Yes, there I should put. Second electron, I should put in py. Then like this I have to put. Understand? Each orbital should be singly occupied with the same spin. What is the spin of this electron? Plus half. This is plus half. This is also plus half. Upward arrow means clockwise. Clockwise spin means plus half. Downward arrow means anti-clockwise, minus half. Okay? Suppose there are 4 electrons. Now 4th electron, what you will do? You will do the pairing. For pairing, you can use any one orbital. 4th electron you can put in px, or py, or pz. Choice is yours. But conventional method, you will put in px, then py, then pz. With what? With same spin or opposite spin? Pairing should be done with opposite. That's an important point. With opposite spin, you have to do the pairing. So this is opposite spin, 4th electron. Understand? 4th electron you can put in px, or py, or pz. Okay? Now suppose here 5 d orbitals are there. 4 electrons you have to place. How you will place? According to Hansul. So when you are filling the degenerate orbitals, you should wait and think about the Hund. What Hund says to you. Each orbital should be singly occupied first. 1 electron, 1 electron, 1 electron, 1, 4 electrons. This is correct way of filling. Are you following? P అయితే ఇలా ఫిల్ చేయాలి, D అయితే ఇలా ఫిల్ చేయాలి. 5 electrons ఉన్నాయి. Then how you will fill? First electron in px, second electron in py, third electron in pz, 4th electron in px, next 5th electron in py with opposite spin. Then what about here? 1, 2, 3, 4, 5th electron here. So each orbital should be first singly occupied. Then pairing should be done. Suppose 6 electrons are there. Then what will you do? 1, 2, 3, 4, 5, 6. 6 electrons are placed. In this case, 1, 2, 3, 4, 5. Then pairing should be done. When you are doing pairing, any one of the orbital you can accommodate. You can take any orbital here. Because all are having the identical energies. Electron, if it go in dxy, it will get same stability. Electron, if it go in dyz, same stability. So it does not matter. But conventional method, dxy. So dxy. Understand? 7 electrons are there, what will you do? Here, how will you fill? If 7 electrons are there. This 1, let me write again. 7 electrons is there. How will you fill this one? Who said that point? Okay. 7 electrons are there. What I will do? When I am filling the p orbitals. I'll put one electron here. 1, 2, 3. According to the same speed. 4, 5th, 6th, 7th electron will go in another orbital. This will be filled. 7th electron will go in next energy orbital. Okay? Here 1, 2, 3, 4, 5, 6 and 7. Because D capacity is to accommodate maximum 10 electrons. Yes, it can hold 7 electrons very easily. But P can accommodate maximum 6. Okay, 6 you are placed. 7th electron will go in the next higher energy orbital. Understand? Now, here we are stuck with the chromium and copper. This is the expected electronic configuration. Expected for copper and chromium. Experimental evidences says that here the correct electronic configuration is this one. Correct, or you can say actual electronic configuration of chromium is 1s2, 2s2, 2p6, 3s2, 3p6, 4s1, 3p5. So here where is the difference lies here? Correct? 4s2, 3d4 changes to what? 4s1, 3d5. Why there is a change? This is in accordance with what? This is in accordance with the. On what basis you have filled these electrons? Opposite principle. They will ask in the exam. NEET లో అడుగుతాడు ఈ ఎలక్ట్రానిక్ కాన్ఫిగరేషన్ ఉంది కదా ఇది ఏం ఫాలో చేసి రాస్తారు అని అడుగుతాడు. ఓకేనా? సో దీంట్లో ఏమేమి ఫాలో అయినారు మీరు బాగా చెప్పండి. ఆపోజిట్ ప్రిన్సిపల్ ఒకటి ఫాలో అయినారు. ఎట్లా? ఫస్ట్ యూ హావ్ ఫిల్డ్ 1s, దెన్ యూ హావ్ ఫిల్డ్ 2s, దెన్ యూ హావ్ ఫిల్డ్ 2p. హూ ఇస్ గైడింగ్ యూ? ఆపో చెప్పినట్లే కదా మీరు ఫిల్ చేసింది. ఓకేనా? రైట్. ఇంకా ఏం ఫాలో అయినారు? Hunt's rule follow or no? Okay, Hunt's rule when it come into play for each orbital filling? Degenerate orbitals. What are the example for degenerate orbitals? Degenerate orbitals example what I gave? What are the examples I gave? P, D and F. Okay. So this contain P orbital or not here? P orbital, D orbital, right? 6 electrons have filled up using the Hunt's rule. 4 electrons he has filled up based on Hunt's rule. Hunt's rule is also followed. Okay, Hunt's rule is followed. Okay, next. Did he follow the Pauli exclusion principle? How you can say Pauli exclusion principle is followed? What Pauli exclusion principle says? Pauli ఏమంటున్నాడు? ఒక ఆర్బిటల్లో 2 కంటే ఎక్కువ ఎలక్ట్రాన్ పెట్టకూడదు తంతాలు లేకపోతే అంటున్నాడు. So 1s is the orbital. How many electrons have space? 2. He did not write 3, 4, 5. 2s also how much maximum? 2 electrons it can accommodate. In 2px, in 2p you are having 2px, 2py, 2pz. In 2px he might have kept 2 electrons maximum. 2py, 2 electrons. 2pz, 2 electrons. 2 plus 2 plus 2, 6 electrons. Like that is space. Understand? రెండు పెడితే కడుపు నిండిపోయింది. 2px కడుపు నిండిపోయింది, 2py కడుపు నిండిపోయింది, 2pz కడుపు నిండిపోయింది. సో టోటల్ 2p కడుపు నిండిపోయింది. అందుకని 6 కంటే ఎక్కువ ఎలక్ట్రాన్స్ రావడానికి ఛాన్స్ లేదు p ఆర్బిటల్. మాక్సిమం 6 ఎలక్ట్రాన్స్ కెన్ బి అకామిడేటెడ్. Am I clear? So like that he has followed all the 3 principles. Okay. Now what about here? The electronic configuration got changed. Now what are the principles he has followed? This is in accordance with this is in accordance with what? In accordance with A rules following. Apo following. Apo following that is wrong. You have done a mistake. According to Apo's principle, after filling the 4s, electron should go in 3D. Am I right or not? 1s, 2s, 2p, 3s, 3p, 4s, 4p, 3D. So 1s completed, 2s completed, 2p completed, 3s completed, 3p completed, then 4s complete after we should go in 3D. 4s complete అయిన తర్వాత 3D లో పోవాలి. అట్లే కదా ఇక్కడ వెళ్ళింది మనం. 4s తర్వాత 3D కి వెళ్ళాం. కానీ ఇక్కడ 4s కంప్లీట్ కాకుండానే ఎలక్ట్రాన్ ఎక్కడికి పోయింది? 3D లోకి వెళ్ళిపోయింది. 4s లో ఎన్ని ఎలక్ట్రాన్స్ ఉన్నాయి? 1. ఎన్ని ఉండాలి యాక్చువల్గా? 2. Means what is violated? Of-Bohr's principle is clearly violated. Yes or no?
Yes.
Then what is followed? That is violated. Of-Bohr's is violated. What about the Hunt's rule? It is followed or violated? Followed or violated? Hunt's rule is applicable for degenerate orbitals. What are the degenerate orbitals? We have 2p, 3p and 3d. 2p, 6 electrons. How many he has placed following the Hunt's rule only? 1, 2, 3, 4, 5, 6. Completed. This also. 1, 2, 3, 4, 5, 6. Completed. 3d, 5 electrons are to place. Okay, 3d. How we might have placed this one? 3d. 1, 2, 3, 4, 5. 1 electron in dx, dy, dz, dx square minus y square, dz square. Like this. Hunt's rule is not violated. So, with the Hunt's rule. Pauli exclusion principle, it is followed. In each orbital maximum, 2 electrons he has placed. Okay? Pauli is also followed. So, what is violated finally? It is of-Bohr's principle. Then, how can you justify this? For writing the electronic configuration, you are following the 3 principles. On what basis that 3 principles are created? For stability reasons. For stability reasons only those principles are created. Then now the stability is gone. How can you justify this configuration? You have any idea? Okay. Now the explanation comes like this here. Students, remember this one, this triangle. This is the stability triangle. This is stability triangle. Then you are filling the electrons. How to predict the stabilities? See, at the top peak what you are having least stability. At the bottom what you are having most stability. Okay. Now when the electrons will get most stability? When the electrons are filling the outer level. Outer level means last shell. Level means shell. Level and shell. Outer level means outer shell. Outer shell means last shell. In the nucleus, I already told you there are many shells, right? If I put the electrons here and here like this, now these shells are called electron shells. What do you call these shells?
Electron shells.
This is first shell. This is second shell. This is third shell. First shell is called electron shell. Second shell is also called electron shell. Third shell, it is not called as electron shell. It is empty. Third shell is not called as electron shell. Yes or no? Electrons ఏ షెల్ లో అయితే ఉంటాయో ఆ షెల్ ఏమంటాం ఎలక్ట్రాన్ షెల్స్ అంటాం ఓకే నౌ వాట్ ఇస్ ద outer shell here? Outer shell means last shell. Last shell means what you will take? Very good, you should take 2. This is the last shell. Actually many students will think that the last shell is infinite shell. Atom lo last shell evaru infinite shell, but it is not that one. That is not correct. Electron shell, last electron shell is the correct word, but you will use it as last shell. Okay, so if that last shell is full, then it will get the extra stability. Atom is already stable. Atoms are stable. Ions to atoms to compare చేసుకుంటే atoms are more stable than ions. Atoms do not carry any charge on their head, but ions will carry the charge. Positive charge or negative charge. Remember, charge in a species ఎప్పుడు unstable. Charge species are unstable, but atom is not carrying any charge, so it is stable. So atom is relatively more stable than charged species. మరి ఆటం ఎందుకు స్టేబుల్ అయిందంటే ఆటంలో ఎలక్ట్రాన్స్ ఆఫ్-బోర్స్ ప్రిన్సిపల్, హంట్స్ రూల్, పాలి ఎక్స్క్లూజన్ ప్రిన్సిపల్ ఫాలో అవుతూ ఎలక్ట్రాన్స్ అరేంజ్ చేసుకున్నాయి కాబట్టి స్టేబుల్ అయింది. వై ఆటమ్ గాట్ స్టెబిలిటీ? బికాస్ ఆఫ్ ద ఎలక్ట్రాన్ అరేంజ్మెంట్. ఇఫ్ ద ఎలక్ట్రాన్ అరేంజ్మెంట్ ఇస్ నాట్ ప్రాపర్, ద ఆటమ్ విల్ నాట్ బి స్టేబుల్ అగైన్. ఓకే, నౌ ది క్రోమియం అండ్ కాపర్ ఆర్ వైలేటింగ్ దట్ స్టెబిలిటీ. They are violating of-Bohr's principle, yes or no? Then how come they are getting the stability? There is one more reason. What is that reason? If the outer shell is full, okay, or there is a full sub-level stabilities, the atom will get extra stability. They will get extra stability. Okay, half level if it is full, full half level, or you can say half field level you can also call. Okay, now let us see. For example, let us take carbon. Okay, 1s, 2s, 2p. This is 1s orbital, this is 2s orbital, this is 2p. 1s, 2s, 2p. 2p are 3, 2px, 2py and 2pz. Okay, so now what is the atomic number of carbon? Atomic number of carbon 6. 6 means first electron you will place here. According to Auber's principle, 1s should be filled. Okay, 1s capacity is maximum to hold 2 electrons. So first electron, second electron you have placed. What you have followed here? Which rule you have followed? You can complete the electronic configuration. Can you do that? What follow here? Auber's principle follow here. Auber's principle prakaram first year fill kavali 1s. Electron ikkada petna 1s lo petna kada 2s lo petలేదు kada. So I followed Auber's principle. Okay, then another what I followed? Polysexual principle did I follow? How do you say polysexual principle followed? There are 2 electrons in the orbital, and both are having the opposite spin. Maximum orbital can accommodate 2 electrons. Oka bed lo iddaru padukuntaru maximum. Okay, muguru padukunte kinda padipotaru. Okay na? 2. Hunt's rule did I follow here? Hunt's rule follow here. Hunt's rule when it come into play? When you are filling the degenerate orbitals. Example for degenerate orbitals: p orbital, d orbital and now I fill what? S orbital. It's not a degenerate orbital. I did not follow any Hunt's rule. Either Hunt's rule is neither followed here nor violated. Okay, next second electron I put here, third electron I put here. Electronic configuration in carbon K: 1s2, 2s2, 2p2. Yes or no? 6 electrons. 1s2, 2s2, 2p2. Now Hunt's rule will come into play. These 3 orbitals are having the equal energy and I have to place 2 electrons. How I have to place the 2 electrons? According to Hunt's rule, each orbital should be singly occupied. బస్ లో మీరు ఎక్కినప్పుడు ఏం చేస్తారంటే ఇది సీట్ విండో సీట్ సెలెక్ట్ చేసుకుంటారు. ఒక సీట్ లో ఇద్దరు కూర్చుంటారు అంటున్నారు, టూరిస్ట్ వెళ్తున్నారు. విచ్ వన్ యూ విల్ ప్రిఫర్, విచ్ సీట్ యూ విల్ ప్రిఫర్? ఇఫ్ ద స్టూడెంట్స్ దే ఎంటర్ ఇంటూ ద బస్, దే ప్రిఫర్ ద విండో సీట్. ఒక సీట్ లో ఇద్దరు కూర్చోవచ్చు కానీ ఒకటే కూర్చుంటాడు. ఫస్ట్ ఒక విండో సీట్ ఆక్యుపై చేసుకుంటాడు, నెక్స్ట్ ఇంకొక విండో సీట్ ఆక్యుపై చేసుకుంటాడు. ఒకటే సీట్ లో ఇద్దరు ముందు కూర్చోరు. అవన్నీ అలా ఆక్యుపై అయిపోయినటువంటి విండో సీట్. తర్వాత ఇప్పుడు సమ్మర్ ఉంది మీకు, ఓకేనా, లేకపోతే వింటర్ లో వెళ్తున్నారు, గాలి ఫుల్ రావాలి, విండో సీట్ సెలెక్ట్ చేసుకుంటారు. అది ఫీల్ అయిన తర్వాత నెక్స్ట్ ఇంకా నో చాయిస్, ఏం చేస్తారు అప్పుడు? ఒక్కొక్క సీట్లో ఇద్దరు కూర్చుంటారు, కేరింగ్ లీడర్. సో లైక్ దాట్ 1 electron will place here, next electron will go in the number. This is one window seat, this is one window seat. Understand? So like that. So what is followed now in whole configuration? What is followed? Auber's principle is followed. Auber's principle is followed. 1s filled, next 2s filled, next 2p. Auber's is followed. Next polyreclusion principle. Each orbital accommodate 2 electrons. 2 electrons. Understand? Followed. Okay. Next here, what is followed? Hunt's rule is followed. So for writing this electronic configuration, I followed all the 3 principles: Auber, Pauli, and Hunt's rule. Okay. Next, nitrogen if I take. What is the atomic number of nitrogen? 7. How many electrons nitrogen contain? Yes. 7 atomic number means 7 protons, 7 electrons it contains. So 7 electrons I have to place. First electron, second electron, third electron, fourth electron, 5th, 6th, and 7. What are the rules I have followed here? Auber is followed, Pauli is followed, Hunt's rule is also followed. Neon atomic number 10. 10 electrons you have to place. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Now you tell me, if you take the neon, this is 2p, right? 2p. Okay. What is the outer level here? Outer level. Outer level is 2s and 2p. Second shell is the last shell. Yes or no? Last shell is completely filled or not? Completely filled. Means there is full outer level. Outer level is full. It means what this neon is having? It is having full outer level. Means this is more stable. Yes or no? Peak దగ్గరికి వెళ్తే stability తక్కువ ఉంటుంది. కిందికి base దగ్గర వస్తే stability increase. Means if you are moving in this direction, stability what is happening? Increasing or decreasing? Stability is increasing. If you go from bottom to top, then what happens? Stability decreases. stability decreases. What about nitrogen? In nitrogen, in the outer level, okay, in the outer level, half filled stability you can see. Yes, sir. Half filled level is there. There is a half filled level. Yes, sir. So which is more stable configuration? Neon configuration or nitrogen configuration? Neon configuration is more stable. Neon ikkada vastundi full outer level lo vastundi. Nitrogen ikkada vastundi half filled level lo vastundi. What about carbon? Carbon lo chusukonte full outer level unda? Ledu. Full subshell unda? Full subshell. 2p subshell is it full? 2p is it full? No. So ఇది కూడా లేదు. Half filled level, half filled అయిందా ఇది? You see this one. This is neither half filled nor full subshell nor full outer level. What it is having? No special arrangement. No special arrangement. So its stability is least. So if I ask you what is the stability of the elements? Carbon, nitrogen, neon. So what is your answer? Neon is more stable than nitrogen. Nitrogen is more stable than carbon. Is that clear? Any doubt? Let me finish this one. Now, here if you take the 4s2 and 3d4, 3d4 it comes under which type of category in this table, in this triangle? 3d4 full outer level vastunda, full subshell vastunda, half filled vastunda, no special arrangement kinda vastundi. D can accommodate maximum how many electrons? 10. If it accommodates 10, then full outer level you can say. Understand? D can accommodate 5 electrons. 5 also. 5 means it is half filled level. Half filled level means stable. Okay? But not that much stable as full outer level. 10 unte baga stable. 5 unte takko stable. Then you put 10 ledu, 5 ledu. What it is having? No special arrangement. So it is not having some extra stability. Understand? Now you see. Here the 3D is half filled. Yes or no? 3D is half filled as well as 4s is also half filled. Half filled level stability it has. Ikkada meeku ledha. Okay na? 4s is filled but 3D is not filled. 4s is filled but 3D is not filled. It means here you are having stability. Which stability you are having here? Tell me students. 4s has 2 electrons. Means in which case it will come? Full sublevel. Understand? Not full outer level. Full sublevel. 4s is the sublevel. Subshell is full. 4s subshell has maximum 2 electrons capacity. 2 electrons is there. So here 2 electrons. Here stability is there. Here you don't have any stability. Yes or no? But here half filled stability is there. 2 advantages are there. Half filled stability. Here also half filled stability. This is S level stability means sub-level stability, and here no special arrangement. This is no special arrangement. Understand? Here 2 stabilities. That's why this is more correct. And what about here? 1s2, 2s2, 2p6, 3s2, 3p6, 4s1, 3d10. Now what you are having here? 4s. 4s is what? 4s is having full sub-level. It comes under what? Full sub-level. Okay. Next. D. What is D? D is 10. Full outer level. D is full outer level. Yes, sir. D is full outer level. 2 stabilities it is getting. Extra stability. There is one more point. If the p orbital or d orbital, p subshell or d subshell, if it is half filled or fully filled, then there are exchange energies. Exchanges are possible. More is the number of exchanges, more is the stability. Exchanges. 1, 2, 3. This is half filled. P3. You can exchange these 2 electrons here. ఈ ఎలక్ట్రాన్ ఇక్కడ పెడితే ఏమైనా అరేంజ్మెంట్ చేంజ్ అవుతుందా? కాదు. ఇప్పుడు ఈ ఎలక్ట్రాన్ ఇక్కడ పోయినా ఈ ఎలక్ట్రాన్ ఇక్కడ పోయినా వాటి ఎనర్జీ మాత్రం మారదు కదా, మారుతుందా? ఇది ఎనర్జీ యాక్సెస్. ఎంత ఎనర్జీ ఉంది? 3 ఎలక్ట్రాన్స్ ఇంత ఎనర్జీ ఉంది. ఈ ఎలక్ట్రాన్ ఇక్కడ వెళ్ళినా ఇంత ఎనర్జీ ఉంటుంది, ఈ ఎలక్ట్రాన్ ఇక్కడ వెళ్ళినా ఇంత ఎనర్జీ ఉంటుంది. సో దిస్ వన్ ఎక్స్చేంజ్ యూ కెన్ డూ. దీస్ 2 electrons ఆల్సో యూ కెన్ డూ వన్ ఎక్స్చేంజ్. ఈ ఎలక్ట్రాన్ ఇక్కడ, ఈ ఎలక్ట్రాన్ ఇక్కడ పెట్టచ్చు. అవునా? ఎనర్జీ ఏమైనా మారుతుందా? మారదు. నెక్స్ట్ ఈ 2 electrons మార్చుకోవచ్చు. ఏమైనా మారుతుందా? మారదు. ఎక్స్చేంజెస్ జరిగినప్పుడు ఏమవుతుంది? ఎనర్జీ లాస్ జరుగుతుంది. ఫర్ డూయింగ్ ద ఎక్స్చేంజ్ ఎనర్జీ లాస్ విల్ టేక్ ప్లేస్. ఎలక్ట్రాన్ మూవ్ చేయాలంటే ఎనర్జీ కావాలి కదా, ఎనర్జీ ఖర్చు అవుతుంది కదా. ఎనర్జీ ఖర్చు అవుతుంది అంటే ఎనర్జీ లాస్ అవుతుంది. ఎనర్జీ లాస్ మీన్స్ ఎనర్జీ డిక్రీజ్ అవుతుంది. ఎనర్జీ డిక్రీజ్ ఏంటంటే స్టెబిలిటీ డిక్రీజ్. సో మోర్ ఇస్ ద నెంబర్ ఆఫ్ ఎక్స్చేంజెస్, more the energy you have to spend to do that. More the stability will increase. Understand? So if I take 6 instead of 3, means if I take the 6 electrons, then exchanges will increase or not? Electrons పెరిగితే exchanges పెరుగుతాయి. Yes or no? Exchanges పెరిగినాయంటే ఎనర్జీ తగ్గుతుంది. Stability will increase. అదే నువ్వు D5 తీసుకుంటే ఎనర్జీ ఎక్స్చేంజెస్ చేయొచ్చా లేదా? 1 2 3 4 5 ఇవి రెండు ఎక్స్చేంజ్ చేసుకోవచ్చు, ఇవి రెండు ఎక్స్చేంజ్ చేసుకోవచ్చు, ఇవి రెండు ఎక్స్చేంజ్ చేసుకోవచ్చు, ఇవి రెండు ఎక్స్చేంజ్ చేసుకోవచ్చు. ఎస్ ఆర్ నో? నెక్స్ట్ ఇవి రెండు చేసుకోవచ్చు ఎక్స్చేంజెస్, ఇవి రెండు చేసుకోవచ్చు, ఇవి రెండు చేసుకోవచ్చు. నెక్స్ట్ ఇవి రెండు చేసుకోవచ్చు, ఇవి రెండు చేసుకోవచ్చు. నెక్స్ట్ ఇవి రెండు చేసుకోవచ్చు. As the number of electron exchanges increases, stability will increase. D10 తీసుకుంటే ఇంకా ఎక్కువ ఉంటుంది. ఎస్ ఆర్ నో? D10 1 2 3 4 5 6 7 8 9 10 number of exchanges will increase. So overall if you compare all this, what is stability order? Stability order D10 more stable. Next D5. Next D5. D10 then P6. ఇది ఎక్కడ ఎక్స్చేంజెస్ ఎక్కువ వస్తాయి? D5 లోనా P6 లోనా? ఎలక్ట్రాన్స్ ఎక్కువ P లో ఉన్నాయి కాబట్టి P6 తర్వాత D5 తర్వాత more is the number of electrons, more is the number of exchanges, more is the stability. Understand? So whenever P is either half filled or fully filled, the atom will get extra stability. Whenever the D is half filled or fully filled, the atom will get extra stability. Is that clear?